Welcome to the Explainer. Today, we're diving into a topic that is an absolute must-know for any quantitative aptitude test: compound interest. This is one of those concepts that pops up all over the place, so really getting a handle on it is going to be a game changer for your score.
Okay, let's just jump right in with a problem that looks like it's been ripped straight out of an exam. You've got your principal, your rate, but look at that little curveball, compounded 8 monthly. This is exactly the kind of question they use to see if you really get how this works.
Now, if that question makes your head spin a little, don't worry, you are not alone. The whole point of this explainer is to take problems just like this one and make them simple. By the time we're done here, you'll have a clear, step-by-step way to tackle this and any others like it super fast and with total confidence.
So, here's our game plan. First, we're going to start with the why. What makes compounding so powerful? Then we'll get into the how by breaking down the main formula. After that, we'll learn how to handle those tricky compounding periods, walk through some actual exam problems, and then finish up with some awesome shortcuts for test day.
All right, first things first. Before we can start solving anything, we have to understand what makes compound interest so special. We need to get why it's such a different beast compared to, its much simpler cousin. So here's the fundamental difference. Think of simple interest as a straight, predictable line. Your earnings are the same every single year. But compound interest? That's like a snowball rolling downhill. The interest you earned last year gets added to the pile, so this year, you're earning interest on a bigger amount. It just keeps picking up speed.
And that's the magic trick, right there. You're not just earning interest on your starting money, you're earning interest on your interest. That little detail, that reinvestment, is the engine that drives that crazy exponential growth we're talking about.
Yep, exactly. Investopedia nails it. It's a cycle. Your money earns interest, that interest gets added back in, and now that bigger pile earns even more interest. It's a self-fueling machine for growth, which is why it's so powerful.
All right, so now that we get the why, let's get to the how. We're going to look at the one formula you need to solve almost any compound interest problem. And the key isn't just memorizing it. It's knowing what every little piece does so you can twist and turn it for whatever the question throws at you.
So here it is. And I know, at first glance, it might look like a bunch of alphabet soup, but trust me, every single letter in this equation has a very specific, very logical job. Let's break it down. Okay, P is your starting cash, and R is your annual rate. Easy enough, but N and T? That is where the exams love to set their traps. N is all about how often the interest is calculated, and T is the total time. Nailing these two is the secret to getting these problems right.
And that brings us right to the most common curveball in these questions: non-annual compounding. It could be semi-annually, quarterly, or even that weird 8-monthly from our first problem. But guess what? The rule for adjusting the formula is always the same.
You have to see the simple logic here. It's an inverse relationship. If you compound twice as often, semi-annually, you have to use half the annual rate, but you do it for twice the number of time periods. The rate gets divided, the time gets multiplied. So for that 8-monthly problem, well, there are 1.5 8-month periods in a year. So you'd multiply the rate by 8 over 12 and multiply the time by 12 over 8. It's all about making the rate and the time period match up.
All right, enough with the theory. Let's get our hands dirty and see how this all works when we're facing some real exam-style questions.
Here we have a pretty standard problem. We've got our principal, our rate, our time, but the key phrase that should jump out at you is compounded every 6 months. That's your signal. That tells you, okay, I need to adjust my R and my T. This step-by-step process is your best friend. Seriously. First, just list what you know. Then, the key moment. You identify semi-annually, which means N is 2. That one fact triggers the adjustments. The 16% annual rate becomes 8% per period, and the 1 year becomes 2 periods. Once you've done that, you can just plug those new numbers into the formula and solve.
And after you run the calculation, boom, there's our answer: $4,492.80. See? By following a system, a question that looks kind of tricky just becomes a straightforward calculation. Okay, let's flip to script. Sometimes they won't ask for the interest. They'll give you the start and end amounts and ask you to find the rate. This is just about doing a little detective work with the same formula.
The approach here is all about isolating R. We just need to do a little bit of algebra. So we plug in our numbers, then we get that bracket by itself by dividing the final amount by the principal. Now, how do you get rid of that squared term? Simple, you just take the square root of both sides, and that cleans the whole thing up, leaving us with some basic algebra to find our rate. Which gives us our final answer. The annual rate of interest is 8%.
This really shows you just how versatile that one formula is. You can use it to solve for any of the missing pieces.
Okay, the main formula is your reliable workhorse, but in a timed exam, accuracy is key, but so is speed. For certain types of recurring problems, there are some really slick shortcuts that can save you precious, precious time.
This shortcut is an absolute lifesaver for those questions about how long it takes for an investment to multiply. If a sum of money doubles in, let's say, 5 years, it's going to become 4 times the original amount in 10 years and 8 times the amount in 15 years. You see the pattern? The amount grows exponentially, but the time it takes just adds up linearly.
Here is a perfect scenario for our shortcut. The money triples in 4 years. We want to know how long it takes to become 27 times itself. Now, the first thing your brain should spot is that 27 is just 3 to the power of 3.
And you can see the pattern perfectly here. To become 3 times itself, it takes 4 years. So to become 3 squared, or 9 times, it's going to take 4 times 2, which is 8 years. To get to 3 cubed, or 27 times, we just multiply that original time by 3. 4 years times 3 gives us 12 years. And just like that, we found the answer without even touching the main formula.
And that's really how you break down and master compound interest for your aptitude tests. It's about a system of logic, knowing your key formula inside and out, and having a few clever shortcuts ready to go. But as you practice this, just remember, the exact same principle of exponential growth that earns you points on an exam is also one of the most powerful tools out there for building wealth over a lifetime.